Good morning, good afternoon, good evening to everyone joining us. First, I would like to personally welcome all attendees and speakers to this third webinar on modern technologies in disaster management. My name is Aman Casey. I'm an intern at the UN Environment Program under the Resilience to Disasters and Conflicts Global Support Branch. It's my pleasure to welcome you to the third part of our webinar series called Modern Technologies in Disaster Management. This series is divided into 4 parts, being robotics, artificial intelligence, drones, and Internet of Things. The first 2 parts focused on robotics and AI, and today we will discuss the use of drones in disaster management. The webinar will give us the chance to learn from and engage with leading experts from around the world as they discuss opportunities and challenges associated with drones and its use in disaster management. Some housekeeping rules before passing the floor to our first speakers for his opening remarks. I would like to remind all the attendees to turn off their cameras throughout the webinar and please keep yourself muted, otherwise it will interrupt the presenters. Attendees can ask questions, however, at any point using the chat function. We have 5 speakers with us today who will take us through their presentation, but first we will start with the opening remarks from Eve Bhaktilami. Eve Bhaktilami is a specialist in geospatial information and resilience. He has been working in many African countries over the past 20 years. Most recently, he has been working for the World Bank, leading Drone for Development study tours in Seychelles and Zambia, and team leader for the Zanzibar Mapping Initiative projects, the largest drone mapping project in the world. Also, for more than 15 years, he has been working for UN Environment as geoinformation expert. Yves holds a master's in tropical ecology and master in geoinformation. It is a pleasure to have you with us. I will now pass the floor to you to give us the opening remarks.
Okay, up to me to speak. Thanks a lot for this kind introduction. So thanks, and really thanks Paula and the intern team for organizing this webinar. Really a pleasure for me and an honor to be invited to give a few opening remarks. I've been working, yes, as you said, for more than 15 years now with the branch, with the UNEP branch, and so it's really great and very excited to see how it is embarking on this exciting, disruptive, and modern technology tour. I'm also happy to share the panel with Patrick. I see Patrick Meyer here, with who I have the pleasure to fly and crash, I must say, a few drones in Zanzibar during the Zanzibar Mapping Initiative project where we covered the entire island of Zanzibar with using a fixed-wing drone pilots, fixed-wing drones with Zanzibari students. So today we have a great panels of specialists who will tell us more about all the latest advancements in drone technologies for disaster management. From my side, I would like to share a few experiences and thoughts on how I see the use of drones from maybe different angles. So at a personal level, I would say that flying drone is really a very exciting activity. I think that you are entering a new world, and you will always remember, you know, the very first time you flew a drone. For me, it was 10 years ago, and after many years watching others flying drones, I finally purchased a small copter drone, and I remember how exciting it was to launch it for the very first time, and then finally be on board of the satellite watching the Earth that I have been doing for long, but just using my laptop computer to see others' satellite imagery. I also remember the fear when suddenly losing my drone, which I think is the case of some of you, maybe if you are drone pilots, and that is not a very good experience. But what's important to me is that as a GIS professional working with UNEP and other organizations on disasters and conflict applications, I think I see drones really as a great tool for sure, as at our disposal, that finally gives us the possibility of getting fresh and fine spatial resolution data so that we can produce maps in a few minutes, which opens the door for sure to many great applications and technologies. As a GIS educator, maybe some of you are, I think that it's also a fabulous, a fantastic entry point to geospatial science, because you can, yes, you can start to fly drones without any geospatial GIS knowledge, but in a way, sooner or later, you will want to understand the science behind drones GPS accuracy, what does it mean to the mean sea level, photogrammetry process, and how to create and use a digital elevation model, which is really core to many disaster risk applications. At the World Bank, where I am also working as a geospatial and resilience consultant, I think we have been using drones for a long time now. And in a way, we have been using them, and we are using them for many applications, operations. So for land administration, risk assessment, forestry management, urban planning, infrastructure monitoring, and post-disaster damage assessment, and much more. And drone is for us, I mean, we are using them a lot in combination with other sensors, like remote sensing, always, street view imagery now, and we combine that, and with artificial intelligence, we extract actionable information. There is potential in using drones for sure for disaster management, to support development operations, and provide also employment opportunities in countries where it develops. But what is important also is that we often say that sky is the limit when it comes to applications. We could also say that regulation sometimes can be the limit, and it's I think normal, because we are operating in one airspace, and we are not the only one as a drone pilots and operators. So this is why also in 2020, 1 year ago, we organized with the World Bank in Africa, the African Drone Forum in Rwanda. It was the very first conference of its kind, bringing drone companies, African countries, regulators, startups, along with governments, and all together to shape the, where the future of African skies, and working and developing these enabling regulations. So the conference was opened by the President Kagame himself, who is a very strong supporter of drone technologies. And we all know, or maybe some of you know, the example of blood delivery using drones with the company Zipline in Rwanda and in Ghana now, and maybe other countries. And in parallel to the conference, we ran a challenge, the Lake Kivu Challenge, a drone competition where companies from all over the world competed during 1 week on 3 different challenges: emergency delivery, pick up samples, find and assess. So a lot of, in a way, emergency applications or disaster risk applications. And since that conference, we are involved in many countries, and we can see that regulation is evolving, changing, and that countries are working really on making them a bit more enabling, let's say, the use of drones, and in a different context. In the UN organization, and maybe we have UN colleagues, friends here today on this conference, I think that, I mean, all of them or most of them are using drone technologies today. UNICEF has initiated drone academies in different places. Malawi launched a few drone testing corridors in Malawi, Sierra Leone, to really test and to push drones to the limits in a safe airspace. World Food Program is also using a lot drones and working on some cargo drone delivery, etc. So drones, for sure, I would say that are here to stay. The technology has proven to be effective, operational for disaster risk reduction, and in many different types of emergency situations. Many applications are still to be deployed operationally with maybe a more enabling environment that would generate local opportunities also. So yes, let's see today what great applications are presented. And thanks again, Paula and the team, and looking forward for this exciting webinar. Over to you. Thank you so much.
Thank you for setting the stage of today's webinar and for emphasizing the importance of using drones in disaster management. Before we start with the presentation of the speakers, we will also have opening remarks from Dr. Patrick Mayer. Patrick serves as an executive director of Robotics, a social impact organization. For more than 15 years, Patrick has collaborated with leading international groups, including the United Nations, Red Cross, World Bank, Planet Labs, Facebook, and 30 plus other organizations. He spearheaded the development of international humanitarian UAV drone code of conduct and organized the first ever humanitarian drone experts meeting at the UN. Since then, he has led multiple humanitarian drone deployments and hands-on professional trainings for numerous partners, including UN OCHA, WFP, UNICEF, and the World Bank. Dr. Patrick, we are very delighted to have you with us today. I will now pass the floor to you. Thank you.
Thank you very, very much for the very kind intro and the kind invitation. Really pleasure to be here. Thank you for organizing this event and bringing us all together. And great to also follow Yves in these opening remarks. I know it takes a lot to actually prepare these events behind the scenes, so we really all appreciate it that you've put this time in to bring us all together. I'll get started with the next slide, please. Thank you so much. So like I think probably many of you here who are kindly joining us from around the world, I've had the privilege of leading multiple humanitarian drone deployments over the years, in my case with and for the United Nations, as well as the World Bank. And as anyone who has led these kinds of humanitarian drone projects will tell you firsthand, drones are at most 10% of the solution in humanitarian drone missions. Next slide, please. Now, the reason that this may actually sound counterintuitive, this 10%, is because we're all really excited about the technology, which of course there is plenty to get excited about. And I loved how Yves also kind of personalized it. This first moment when you get this drone up in the air, it really gives you a sense of maybe freedom that we don't otherwise have because we're bound by the laws of gravity. So it is an exciting emotion. But you know, and I do share the sentiment in this particular quote here, right? That yes, we definitely are on the very edge of exponential growth in the drone industry, and that it definitely has the potential to transform our lives for the better. And of course, that has to be a goal working towards. But now we also need to unpack some of this language. And here, feel free to add forward with the slides with the animations, but basically just to run this through is, yes, so first it's like who exactly is on the edge of exponential growth in this particular case? Then whose lives will actually be transformed for the better? And then who will get to lead that transformation for better lives? Who gets access to the exponential technology in the first place? And then who gets to be called an expert? Who gets to be make a career out of this incredible opportunity? Next slide, please. So I've had the opportunity, as Aman very kindly mentioned, to work and learn in the humanitarian technology space for the past 15 years. And from my own experience, I can tell you that, you know, the vast majority of discussions when it comes to the use of emerging technologies in humanitarian contexts is really centered on which technologies to use and then how do you actually use them. Next animation, please. And, you know, barely 1% of the time is actually spent on asking the question or even discussing like who actually gets to use these technologies in the first place. Now, there are many reasons for this, but one of the, I think the main reasons is that if we start asking who, that becomes a bit more provocative because it inevitably leads to questions about power, racism, and yes, colonialism. Whereas if we stick to the safer technology questions, that simply leads to simple discussions about, simple but important discussions about which technology to use and how to optimize this technology. Next slide, please. And this, in part, I think explains why we see across the humanitarian sector and global development and other sectors, projects that are largely foreign-led, top-down, and technocentric. Next slide, please. So this results in all kinds of shenanigans, right? So we have foreign, experts parachuting into countries with drones and other technology, where the role of the affected local communities is to be the passive observer and possibly to hold the umbrella so that the foreign drone pilot doesn't get wet. Next slide, please. We also see examples of a Canadian drone company parachuting into Kenya, which is not next door to Canada, to provide drone training, when in fact there are fully qualified and highly experienced Kenyan drone pilots who can give the training and continue to directly support their own Red Cross, because they won't actually disappear back to Canada the day after the training. And so I'm just highlighting these two examples, but they're just two of countless examples that I come across on a regular basis. Next slide, please. And then another reason why I think our fixation on the technology is misplaced and indeed can actually be harmful is because flying drones is at most 5% of what goes on in humanitarian drone deployment. And again, just speak to anybody who has deployed drones in humanitarian projects. Anybody will tell you this firsthand, right? And next slide, please. Oh, there's some animations, but we can jump through those. Now, the other 90% of the time in these missions, in these projects and deployments goes into a wide range of other tasks and responsibilities that are the much less sexy ones for some people, right? And what does this include? This includes community engagement, informed consent that doesn't happen automatically or at all, data protection, flight permissions, overall coordination, as well as communications. There is contracting and subcontracting. There's you want to be ready for interviews, so media relations, and then of course when the drone lands, rather than crashes, hopefully, data processing, data analysis, data sharing protocols, and lots more actually come into play. Next slide, please. And again, thanks. And anyone who has deployed on these humanitarian drone projects also knows how absolutely essential local expertise, local knowledge, and lived experience is. And on our side at We Robotics, that's why we co-create flying labs with local experts around the world. And flying labs are simply locally led independent knowledge hubs where local experts and partners combine their local knowledge with emerging technologies to drive positive social change. Next slide, please. You can just skip through all that. Thanks so much. And also, as I think we all know by now, first responders by definition are local communities, local partners, and local experts, which explains why flying labs have been involved in dozens of locally led humanitarian drone deployments over the years. And you can learn from their expertise and firsthand experience, as well as ours at We Robotics, in this peer-reviewed professional training that's available online. So next slide, please. To conclude then, when I get asked by different UN agencies and other international organizations and NGOs whether they should invest in drones, my answer is no, absolutely not. You should be investing in local drone experts instead. And so I would ask that, the next time you hear any presentation on humanitarian technology, I would beg you to ask the following questions. Who gets to use this technology? Who gets to be the expert? Who gets to make a career out of this technology? Thank you very much.
Many thanks for these opening remarks, Dr. Mia. We are very honored you could join us today. As we move forward, we will hear the practical implications of drones in different stages of disasters. Today, we have invited 5 panelists. Each of them will provide a 10-minute presentation, and at the end, we have allocated some time for discussions and Q&A as well. It is now my pleasure to introduce our first speaker, Mr. Cameron Schell. Mr. Schell is chairman and CEO of Dragonfly and has been a technology entrepreneur for more than 30 years. He has spent his career growing a diverse collection of high potential ideas into revolutionary companies that have changed the way we experience the world. Cameron takes a hands-on leadership role in projects, infusing innovation and adoption with the operational principles of clarity, alignment, and measurement into the culture of every team he works with. Over to you, Mr. Cameron.
Thank you very much. It's a great pleasure to be here, and really appreciate being able to participate with the UN Environment Program as well as the other esteemed panelists. Today, I'll just give a quick presentation on our view of what's happening with emergency and disaster response, and actually give a couple of use cases, if that's okay. So we really view drones as part of the fourth industrial revolution of technology, and in particular for disaster management. Dragonfly has been a drone manufacturer and solution provider for the last 20 plus years. And in many circles, we're recognized as the oldest drone manufacturer in the world. And in fact, the first drone that was ever credited with saving a human life was a Dragonfly drone. And to date, that was in a search and rescue mission using thermal cameras. And today that drone sits on permanent display in the Smithsonian. And it's a real point of pride for us as an organization, and something that we'd like to continue with in terms of providing these essential services. And we do think drones will play a pivotal role in these essential services. Next slide, please. So when we look at disaster management and drones, we really look at it in three kind of buckets, if you will. And building a little bit on what Patrick just previously had to say, and in fact, whether it's disaster recovery or with any of our clients and customers that we are lucky enough to work with, drones really are a small part of the equation. Certainly for an organization like us, you need to have drone expertise, and whether it's in piloting or manufacturing or whatever the case is, but it's in all the other pieces that come together. The drone just ends up, kind of being the representation of a successful mission. So first and foremost is always readiness, and I really sense that the world in general and emergency response organizations are getting to the point where they're having very important organizational conversations about being ready. So the conversations today aren't if we're going to use drones. They're like, wow, these are an incredibly effective tool. How do we use them? And more importantly, now that we have a sense of how we're going to use them, because we're getting clarity from regulators and such, is what infrastructure do we need to put in place? What other ancillary pieces of the whole ecosystem do we need to have in place in order for this 10% of the equation, as Patrick set out, to be effective? And so, we really need to be in a situation where we got infrastructure and people that are trained and ready to go. So speed and agility in any of these situations is great. So it doesn't make any sense to add something new into a disaster management equation if you don't have everybody trained up, and if everybody isn't practiced, and if you don't have the right equipment. The last thing you need in these situations is more confusion or any novelty. Novelty is definitely not something that is appropriate during that disaster response phase. So, and then the supports and logistics, exact same thing. You've got to have all of that stuff built into it. And then effective communications. So you're adding new devices, you're adding new complexity, you're adding new capabilities for sure into theater. But when you do that, you have to have even stronger communications to be more effective. So the next thing that we really focus on is, okay, what is the actual response, that whether it be technique or whether it be planning or whatever the case is, but really need to have situational awareness. So advanced planning for areas where there are potential disasters that happen, maybe known earthquake or tornado zones, or known disease outbreak areas, or known famine areas, or known areas where there aren't road access. You've got to have advanced planning to it. Yeah, I mean, if you have to run and go on the fly, you do what you can, but the more situational awareness that we can build up front, the better. We also look in terms of responding in terms of survivor identification and being able to provide real-world intelligence, real-time intelligence on what's happening in that particular area. And I'll talk a little bit about that in the use case scenario. And then obviously supply delivery. So again, this comes back to the readiness piece, but you need to know that you've got the right types of supplies to get in there. And if you're organizing all that once a disaster or once a recovery is required, you're losing precious time, and there's already existing infrastructure in place that can probably supply or support in a better way. So we're really talking about creating something here that isn't necessarily an incremental improvement. This is a step change, but in order for the step change to be effective, all that pre-work needs to happen, which is again why it's just so incredible to see seminars and webinars like this and the global initiatives that are really starting to happen. And then finally, drones play a fantastic role in recovery. So whether that's assessing or damages or mapping areas or doing insurance inspection or looking to be able to do pre-planning for the next potential missions that exist out there, that's the type of stuff where drones are just can help avoid being in situations again where we've got maybe as acute disaster response required. Next slide, please. So the specific use case that I'd like to talk a little bit about is, and there are numbers of them that we're working on, but the one I'll just draw attention to because it really encompasses a number of the things that we talked about previously in the last slide is currently we're working with a company called Cold Chain Technology Services. And Cold Chain is one of the largest providers of logistics to the US government for things like vaccine delivery. So they provided all the COVID-19 vaccine logistics into the city of Chicago and the state of Texas and many other places. And so they're standing up an emergency response system utilizing drones for the entire state of Texas. And so this will be used obviously for the delivery of vaccines in the current pandemic, remote location access, offshore rigs, those types of things. But also in terms of disaster recovery or emergency response, to be able to drive in, or excuse me, to be able to fly in or drive the initiative of getting in things like blood and drugs, medical equipment, bandages, water, all of those types of things. Often we'll see some of the protocol in those disasters where you've got drones that have smaller emergency packs that are coming in, but they're actually doing situational analysis first. There's two typical cases they're building for right now. One is acute accidents, critical situations where blood needs to be delivered immediately. So in the state of Texas, and I don't know the exact stats, but they have a very limited amount of blood that's available for accident victims at any given time. And when you start organizing, bringing that in by helicopter to a crash scene or something like that, it's terribly expensive logistics and highly dangerous. And so they're setting up a system whereby they'll be able to do that utilizing drones. The other scenario is more disaster response, where you've got drones coming into the area with emergency packs, but providing situational awareness. Where's the disaster happening? Where are roads blocked? What are the conditions of the survivors on the ground? And being able to provide triage information back to the trucks that are rolling or the boots that are coming into the area quickly. Drones, in our opinion, will be the first responders of the very near future. They can provide, with the manpower of only a few people and a light crew, you can just gather incredible information and deliver, fantastic relief immediately into critical situations while you've got your mass of people coming in to manage a disaster that's unfolding. And so while some of the the drones that we're designing for emergency response will have things like the quick payload swap out. So whether you need to deliver in, temperature sensitive equipment, or whether you need to deliver in larger type of equipment, you've got drones and personnel that are equipped to do that based on the assessment that was initially done by those quick supply drones. Next slide, please. One of the areas that we're really excited about, and I'll just tell a very quick customer story here, is the ability for drones to actually provide medical assistance. And the first area that we're seeing practical application of this in is with the technology that we have called Vital Intelligence. And Vital Intelligence does vital sign monitoring. And basically what happened is we had a public safety organization in the state of Connecticut about 2 years approach us, and they had a requirement to measure mask wearing and social distancing, in public areas. They wanted to see if there were particular public areas that were acting as geographical super spreader locations. And so we deployed an AI technology and machine vision technology utilizing only cameras on the drones. And we successfully were able to measure social distancing and mask wearing, if people were strangers, if they were family units, and a number of things. A successful deployment. One of the personnel made kind of an offhand comment at the end of the deployment. She said, well, it would be great if you could detect COVID-19. And we all kind of chuckled, but we ended up within a day or two taking it quite seriously. And within 9 months, our cameras were able to detect, not COVID-19 specifically, not yet, but we are able with our cameras to detect infectious conditions. So our cameras can now detect heart rate, respiratory rate, blood pressure, blood oxygen levels, heart rate variability, and of course, if it's thermal, then we can detect temperature as well. Now, in the case of COVID-19 and many other infectious conditions, temperature may be asymptomatic or may be variant because of other environmental situations. But things like an SpO2 that is low, or heart rate variability, or blood pressure and things like that, these are not asymptomatic type situations. And so what we've got is we've got drones that are flying into areas now on test that are actually providing survivor status and triage information back to the trucks that are rolling. So we can take a look at a population, or we can take a look at people that are stranded in a situation and get a quick vital sign assessment while emergency flies are coming in, and be able to relay that information back. Who's most serious? What's potential situations? And of course, these types of vital signs are not indicative only of infectious conditions, but they're also indicative of things like shock or trauma. These are the areas where we see now that drones are becoming highly, highly effective. This, amongst many other things that we're working on right now, we think are really the future and the potential of drones. And we really want to thank the UN and all of you for the opportunity to speak on this today.
Thank you, Mr. Cameron. I know the time is very limited, but we really appreciate you managing to squeeze all that knowledge into 10 minutes. We will have time for the discussion in the Q&A session as well, so I will encourage all the participants to ask the questions in the chat box. We will now have our second speaker, Professor David Scaramuza. David is a professor of robotics and perception at the University of Zurich, where he does research at the intersection of robotics, computer vision, and machine learning, and aims to enable autonomous, agile navigation of microdrones using both standard and neuromorphic event-based cameras. He pioneered autonomous vision-based navigation of drones, which inspired the NASA Mars helicopter, and has served as consultant for the United Nations International Atomic Energy Agency's Fukushima Action Plan on Nuclear Safety. We will now pass to the intervention of Professor Scaramuza. Thanks.
Your microphone is speaking in energized.
Please turn on your audio.
I'm sorry, it looks like we're having a little bit of trouble with sharing the audio. I'll just request to hang on a minute and let's see if we can figure that out. I'm really sorry about this.
Good afternoon, everyone. Thank you for inviting me here. So today I would like to talk to you about the work that I've been doing together with my lab, the Robotics and Perception Group, over the past 10 years on building autonomous drones for search and rescue applications. So I think that the key challenge for today's robots is actually to get them into the rubble. And it's not me only saying that, but it's the whole scientific community. So what you see here is an article that describes the use of drones after the accident about the building that collapsed in Miami this summer that killed, unfortunately, more than 100 people. More than 9 drones were actually deployed to get an idea of the whole situation around the rubble, but no robots were actually deployed into the rubble. Search and rescue people still relied on dogs and their own human skills, manual skills, in order to find the survivors. This is because the search and rescue robotics is very, very, very difficult, and we are just scratching the surface. So what can drones do nowadays, or what will they be able to do? It may be, within 10 years from today. I think what will be feasible and what is already feasible to a certain extent is to have drones, autonomous drones, be used to find and localize victims, survivors after disaster like a tsunami, an earthquake, or in a forest, or in buildings that are only partially collapsed or at risk of collapse. Drones, in fact, can fly, around obstacles, and they can get to a certain point much faster than ground mobile robots. Now, in order to achieve this goal, there are 4 key requirements that the autonomous drones will have to have, in my opinion. The first one is to have a morphing shape. The second one is a level 5 autonomy. That means the drone should be able to fly without any human input. The third is that the drone should be fast. And fourth, it should be small and lightweight. I want to go through each of these bullet points. Let's start with morphing shape. What does it mean that a drone should have a morphing shape? Well, a fixed shape cannot get you that far because often the obstacles that you encounter might be smaller than the size of the drone itself. So a few years ago, together with colleagues from EPFL, we came up with the idea of having a drone that can change its shape by morphing, basically its shape, depending on the environment that it has to pass through. So here you can see that it basically squeezes through in order to pass through an opening, and once it's on the other side, it reopens the arms in order to gain full stability. Thanks to this concept, the drone was able to then perform an inspection of a search and rescue area. But we also showed in the lab that thanks to this shape, we can pass through vertical openings. We can also open the front arm to inspect a surface from close by, or we can also use the arms to grasp a small object and transport it to another point. The concept is pretty simple. So basically here you can see an illustration of how it works. Let's look at the top right pictures first. So in addition to the 4 motors that you need to fly, this drone also has 4 servo motors that are here, 1, 2, 3, and 4. These servo motors actually control the orientation of the arms, and they can be actually oriented in different orientations, completely one another. However, there are 3 positions, 3 orientations that actually are most used in our vision. The first one is the basic position, where basically all the arms are fully open. The second one is what we call the configuration for horizontal gaps. So you can see an idea here, where basically this H configuration, because it looks like an H, is used to pass through horizontal gaps. And then we have the fully folded configuration that is actually very convenient to pass through very small openings, especially vertically. Okay. And once inside, the drone would reopen the arms because the fully open configuration allows the drone to have to be more stable in the air. Also, you can see here in this concept that, for example, you can use two of the arms to grasp a small object like a walkie-talkie that can be used in order to install a communication with the survivor inside the building. Now, also what I would like to talk about is level 5 autonomy. So the drone, if the drone of the future should be able to fly without any human input. So it should be able to explore the environment. It should be able to do also light dense 3D mapping, and it should also be able to do reconnaissance. So in order to accomplish all these things, the drone should be able to actually see the environment. And so it should be endowed with one or multiple cameras. And here you can see, for example, our drone with 4 cameras, 2 on top and 2 on the bottom. And also, in order to do this, the drone should be able to process all these images in real time in order to be also as fast as possible. So for this, we also need a very powerful computers. And what you can see here is basically the brain of the drone. Another key requirement for future autonomous drones for search and rescue is that they are actually fast. Why they need to be fast? Because by going fast, drones will be able to cover longer distances. And this is important because the battery of drones is currently limited to 10-20 minutes. So in order to be able to explore a full building, for example, you need to fly fast. So we are actually working on a fast navigation, fast autonomous navigation in MLab. And here you can see a drone that actually learned to fly at speeds up to 40 kilometers per hour in a forest. And this can be used to search and rescue people in forests, but also later in buildings. Now, in order to learn to fly and to test all these algorithms, actually you need tons of data. Now, it's impossible to go out in the wild and collect, a huge amount of data. So what we are doing in MLab is that we are relying more and more in simulation, because simulation is fast, it's cheap. You don't destroy drones in simulation. It's especially also safe because, when you test all these algorithms in the real world, you're going to actually possibly crash a lot of drones, which cost a lot of money and can also, injure us, the researchers. So simulation is fast, it's cheap, but it's also very safe. And in simulation, we can actually simulate an almost unlimited amount of environments very, very safely. And then what we do is that we deploy these algorithms in the real world, and you can see that in this video that the drones actually, are capable to accomplish the task only by learning in simulation. Now, other things that we are currently working on is to make drones smaller and smaller, but also that is challenging because at the moment, these algorithms that I've shown you, run on sophisticated, advanced computers. However, what should we do in order to run these algorithms on tiny drones? Because tiny drones are very useful because they can get into narrower gaps, and especially in environments where, not even humans or dogs can go through. And so we are working also with other colleagues from ETH in order to build artificial intelligence algorithms that can run on very small computers. Here you can see a computer that consumes only 64 milliwatts, which is less than the power consumption of a tiny camera, and that can be actually installed on a drone that weighs less than 27 grams and is the size of 8 centimeters, so less of the size of a palm of your hand. But this is, things that will probably come in a decade or 2 decades from today. And with this, I would like to conclude. I thank you for your attention, and especially the guys in my lab that did all the impressive work that I've shown you today. If you're interested to follow our work, you can follow us on social media, YouTube, Twitter, and LinkedIn. Thank you for your attention.
Thank you very much, Professor, for your very informative presentation. He had some issues, so he dropped out, but he would be live for our Q&A session, so I would highly encourage the participants to just ask all the questions if you have any queries. Let's move into our third speaker, Mr. Dumisani Kaliati. Dumisani Kaliati is a drones for good innovator and social entrepreneur. He is the founder of Micromac, a Malawian-based hardware startup that is locally developing low-cost autonomous fixed-wing drones made from 3D printed parts and recycled materials for the delivery of medical diagnostics in the hard-to-reach areas of Malawi and for environmental monitoring. Dumisani is also co-founder of the Marketspace, a digital hardware innovation space that provides physical workspace, tools, and business development support to local youths in Malawi. Dumi, the floor is all yours.
Thank you so much, Shamani. I think we can start the slides. All right, so I'm Dumi Kariati, founder of Micromac, which is locally building low-cost drones for environmental monitoring and delivery of medicine in the hard-to-reach areas of Malawi. Next slide, please. So what's the challenge in Malawi? Malawi has some of the highest HIV rates in the world, with 10,000 children dying from it every year. Rural population is about over 80%, and it is characterized by poor road networks and bad terrain. According to UNICEF, it takes 11 days to get samples from remote heavy centers to urban heavy centers, and up to 4 weeks for the results to be delivered back. The most modern mode of transportation currently are bicycles and boats. And you can see that these are slow. And imagine if an HIV positive mother gives birth and they want that baby to be tested, then you need to be urgent. The other challenge in Malawi is whereby in rainy season, floods completely cut off road networks, and health care as well as education are the most affected. Next slide, please. So the areas that are mostly affected are in the southern region of Malawi. For example, Chikwawa, for the past 3 years, we have been hit by Cyclone Idea and others. So our solution is a local-made aircraft, drone aircraft, which one has a use case for medical delivery and the other has a use case for environmental monitoring. So our drones can carry a payload capacity of 0.5 to 1 kg with a range of about 30 to 40 kilometers, depending on the type of payload that we are carrying. Next slide, please. In these aircrafts, they are battery powered, which means that electrical. We have batteries running on 3S and 6S with different battery capacity, while the other aircraft that you're seeing is dedicated to environmental monitoring. These drones are made locally, in-house. We have a 3D printer for 3D printing internal parts, as well as we are recycling foam to make the wings, both using manual way as well as using a CNC machine. The drone that you see here can carry a camera payload or a sensor payload of up to 0.8 kg. Next slide, please. So currently, Micromac is running a pilot phase in the UNICEF humanitarian drone test corridor. Malawi is one of the countries, the first country actually, that introduced the drone corridor in partnership with UNICEF and the government. Within this corridor, we are doing continuous research and development. Since we started focusing on the drones in 2018, we have actually come up with about 3 drone versions. One is a fixed wing drone that was taught to us by the Virginia Tech University. And then our local team has went ahead to improve the aircrafts. We now have a vertical takeoff with 4 rotors, as well as we have one which is a twin engine. We call it a tail-seater. All this we are doing based on the data that we've been able to carry. So at first we had challenges with takeoff, because during takeoff we had to do bungee launch. And with that, there were certain challenges where our success rate was quite small for both takeoff and landing. So we had to improve the drone versions based on the environment where we're operating, as well as the community that we actually work with. Next slide, please. So as our model, what we do is we identify remote communities that are in need. For example, the picture you see in the background is a remote health center, whereby the clinic operates only once in every week because of limited resources. So we identify already existing health centers as our drone delivery points, and then we collaborate with the communities and the chiefs. Next slide, please. Within this, we also conduct surveys in order to identify the challenges as expressed by the community. So we don't dedicate or decide what the challenge is, but rather we learn from the communities. Currently, we have about 65 women and children from 5 communities that are our early users that are testing out the drone delivery system. We have done 720 deliveries on rapid self-HIV test kits, pregnancy test kits, and cough syrup, as well as face masks for children. The data that we collect in the communities, it's data that can help to improve last mile delivery in remote areas. Next slide, please. So within the environmental monitoring sector, Micromac is able to map water sources. For example, this is Lilongwe River, whereby we were sent by a client to collect data. This data is used, for example, to analyze potential malaria mosquito breeding sites, as well as to analyze flood risk areas where floods are most likely to occur, and how can the response be, how well can governments as well as communities be able to prepare for such disaster response. Next slide, please. So another sector is whereby once we collect this aerial data, we're able to analyze using different analysis software, be it a 3D capture or be it drone deploy and other. Within this, as you can see, this is one of our sample data collected. It shows vegetation cover and farmlands as well as communities. In the places where you see green, you're able to see that there is vegetation cover. While in the areas where it seems sort of red, you can see that those are bare lands. So by collecting such data, communities, governments, and countries can be able to know how man-made and natural activities are able to affect the environment, which without drones, that process becomes hard to do. Next slide, please. So Micromac's unique approach is around STEM education, where we're not only building drones for ourselves, but we're able to train other young people in the building of the drones. So far, we've engaged over 300 youths aged 15 to 24 in the operations as well as production of our drones. Within the target group, about 60% are girls. And within the same group, about 5 have been certified as professional drone pilots by the Department of Civil Aviation in Malawi, while about 20 are able to enroll in tech careers. So it's STEM education. By building these pilots, as well as by training others, one, they stand as advocates for our work, because these are likely to occupy decision-making positions in the future. Or at the same time, we are training pilots that help us in the scaling of our work. Next slide, please. So within our work, we've been able to work with different partners, starting from the Virginia Tech University to the Social Impact Incubator, among others. Next slide, please. So how can we make drones work in disaster management? So one will be like what Patrick said. If we can localize drone production and operations to support local ecosystem and entrepreneurs, whereby the international drone players and expertise can be able to share their knowledge as well as expertise with the local drone manufacturers and as well as innovators. Secondary is whereby if development organizations can be able to create enabling drone policies and environment. For example, the drone corridor in Malawi, it's boosting a lot of innovation, and that is one of the enabling environment. So if there can be more of those, then we can see a big boost in the drone industry sector, as well as a help in the disaster management. Another sector where we're looking is whereby we can create deliberate business opportunities, whereby contracts are given on a deliberate basis, only targeting local drone startups, as well as if we can build on open source hardware to build multispectral cameras, as well as data analysis software, because these at the moment are at a high cost and are a hinder. I think next slide. So Micromac has the team, starting from myself, up to the team of media as well as committed development managers. Next slide, please. All right, thank you. That's what we had from Micromac. Thank you so much.
Many thanks for your interesting presentation, Jimmy. Now we move into our fourth speaker. We have Professor Taichi Furuhashi. Professor Furuhashi is passionate about mapping, connecting local communities with maps, and sharing knowledge to empower people. As you know, huge earthquake and tsunami destroyed a lot of cities and local communities in East Japan area in 2011. They are trying how to make more resilient society with mapping, panorama VR, and drone technology. Mr. Furuhashi is a professor of Ayaga Mugekin University and president of Crisis Mappers Japan. Now he has started Drone Bird project with drones for disaster crisis response. Professor Furuhashi, I will now pass the floor to you.
Hi, thank you. So this is Taichi from Japan. And today, thank you for the great opportunity. Today, I would like to share about our use case and experience. So, and how to optimize and how to comply with the domestic aviation law for drone mapping. And today, I have only 10 minutes, and but my slide have about 50 pages. Please switch to the next slide every 10 seconds automatically, please. And maybe I will add yes. And I'm a Taichi, and I work with our university side and also NPO side. Mainly, we are collaborating with OpenSmart community with drone technology. So the organization name is Crisis Mapper Japan. Yes, next, please. Yes, and our team, we have a major two projects. So Drone Bird and Japan Flying Labs. So Japan Flying Labs collaborated with Robotics, already Patrick explained. And today I would like to explain about our Drone Bird project for crisis mapping. And our experience, so in 2011, big earthquake and tsunami attacked to Japan. And next. Yes. So this is the tsunami affected area in Japan. So, and maybe you can confirm about there is a SIP on that building. So, and yes, next please. This time, so I went to this area and I bring drones and I detected the area photo data for that also mosaic data like this. So maybe you can understand that the upper right corner, so that ferry exists. And also, yeah, sometimes, yes, next please. So this image has a serial station, maybe please, next. Yes, this is a red gate. That is a very traditional Japanese shrines gate. So anyway, those three associations, we have the many experience, and that is my first response with using by drones. So, and we understand, next please. Yes, so yeah, Japan's cities, we have to make more resilient society. So that resilient society is very important, we understand. And yeah, we think drone technology can support those new cities and society. So resilient, how to make those resilient society. Yes, next please. So, and we discussed with many people and we call, so drone collaborative societies a good answer, we think. And in Japanese, so that is a drone zentei shakai. So please, next. Yes, our images are like this. So not only for surveying, so maybe, so yeah, deliver drone or rescue drone, or many, there are many types of drones. So, and if a disaster happens, so the technology can support for our society. Yes, next. Actually, after the 2011, So we collaborate with firefighters team like this. So many times we explained how to work drones for the rescue team and firefighters team. Yes, next please. And then, so we have started drone bird project. So like the Thunderbird. So drone bird team is collaborated with the citizen side. So we want to use drone technology for crisis response situation. Yes, next please. Yeah, if you have interest, so this URL and QR code, maybe you can watch our video on YouTube. Yes, next please. And this figure made by our side and World Bank, GFDRR. So, and if natural disaster and very serious disaster happens, so our team, drone bird team, we went to the affected area with our drones, and we will detect the aerial photo data. And next, so we will publish those aerial photo data and also mosaic data as open data into the open aerial map and GitHub or other open platform. Yes, next. So example, in 2019, so big typhoon attacked to Japan. Yes, please, next slide. Yes, this year, 2019, so 2 big typhoons attacked to Japan. So this is one typhoon that name is Hagibis. And after that, yes, we bring our drone. Mainly we are using fixed wing type of drone. And so we detect a lot of aerial photo data for huge area.
Okay, ma'am.
Like this, yes, thank you. This is our example in Kimitsu City, Chiba Prefecture, Japan. So yeah, fixed wing type of drone can cover a very huge area. So for that, this is a flood area with a stream. So next, please. Please, next. Yes. So this is a round slide. So there, Japan and other countries. So there are many types of natural disaster. So landslide, flood, or earthquake and tsunami. Yeah, many times. So we have to take a lot of aerial photo on those crisis situations. So that is our activity. And but very important things. So how to comply, how to optimize with domestic aviation law for drone mapping. So yeah, that aviation law is very sensitive. So that is a Japanese government size official document. So in Japanese. So yeah, there are many regulations. So made by those aviation law. Yeah, next please. So example, in Japan, so our aviation law has an altitude limit 150 meters. So if we want to fly over the 150 meters, so we have to make more document and we have to submit and we have to get permission, special permission. So generally we can use only under 150 meters. Next, please. So and another regulation. So we have the flight restrictions over DID areas. So DID means density inhabited district. So yeah, huge, high population area. So like the city. So we can not use our drone in the center of the city. So yeah, that is a very big issues and how to comply. So with domestic aviation law for drone mapping. Yes, our answer is making agreements with local government. So, and in Japan, we have about 2,000 local governments, so municipalities. So, and we have 33 agreements with local government like this around the Tokyo area. So, and so this area, we can use our drone for the disaster response situation. So actually, this photo means there are many mayors in the local governments. So, and many times I explained, and we have to make agreement, and those agreements can provide exceptions for disasters. So if we want to use, if we want to fly over the 150 meters, so that agreement can support. Yes. And also, agreement is very important. And so we have to add more ideas. So we call disaster drill 2.0. Yes. So Japanese municipality, local governments have the traditional annual disaster drill with citizen side. And so we can collaborate with those disaster drill, and we can add new technology. So we call disaster drill 2.0. And many times we have to show that as a demonstration, and we can share sample data. And so many times we have to explain so that the technology for citizen side. And in this year, so last month, so we started new VTOL type of drones, and so many times, so I have to explain fixed wing type drone, multicopter type drone, and VTOL type. So, and those technology can support for citizen. So that process is very important, we think. Yes, and when we take air photo data, so immediately we have to provide also mosaic imagery using by photogrammetry tools. And now we are making our working process. So yes, please, next slide.
Sorry to interrupt, Professor Furuhashi. Yes. Due to the time limits, if you can please wrap it up in the next few minutes. Thanks.
Okay, please jump to that, maybe, yes, please skip, yes. So many times we are compared those photogrammetry tools. So, and after that, we have to provide publish on open area map like this. Yes, please, next. Okay, and also we are adding Raspberry Pi device into the this affected area, collaborated with UN vector type toolkit, so like this. And if we can use those devices, so we can work on without internet. So yes, next, please skip. Yeah. Yes, like this. So collaborated with GSI, Japan Surveying Institute. Yes, shall we make drone collaborative society? Yes, thank you so much. And sorry, the time.
Thank you so much, Professor Furuhashi, for the insightful and interesting presentation. I'm really sorry about the interruption earlier, but due to the time limits, we have to move on. So last but not least, we have Dr. Ning Wang. Dr. Wang is an ethicist and political scientist based at University of Zurich. She acquired her master's degree in applied ethics and political science from Norway and Sweden, respectively. She worked as an ethicist for a number of international organizations in Geneva. In 2017, Ning returned to academia, carrying out research on the topic of value-sensitive innovation at the University of Zurich. Dr. Wang has a broad research interest in the ethical assessment and responsible governance of emerging technologies applied in the broader context of public health. Through empirical case studies, she aims to address the ethical, social, legal, and regulatory challenges that the new technologies pose to society, explore responsive analytical approaches in the understanding and evaluation of them, and propose practical tools and policy outcomes for the development and governance of them. Dr. Wang, I'll now pass the floor to you. Thank you.
Thank you, Aman, for this kind introduction. And it's a great pleasure to be here with you all and with the UNEP and the audience. Next slide, please. So in today's presentation, next slide, please. I'll start off by providing a background. I think the next slide, please, about my research. Next slide, please. Including key concepts like the good drones or humanitarian drones. I'll then introduce why ethics are important to the humanitarian use of drones. And to give the audience an overview about the ethical implications, I thought it could be interesting to tap into what has been discussed in the literature. So I'll briefly present the results of a scoping literature review my colleagues and myself conducted last year. This is just to spark some interest about the ethical aspects of the humanitarian use of drones. Finally, I look forward to a live discussion with you all. Next slide, please. So as previous speakers have shown so far, small drones have a number of remarkable socioeconomic impacts, thanks to its high versatility and easy maneuverability. And around the beginning of the 21st century, as you can see on this slide, we saw an increasing use of the so-called good drones, whereby a subtle transition from their military origin to the modern time commercial use took place. This evolution continued. Next slide, please. And about a decade ago, drones started to be seen as a technology that can be leveraged upon to assist humanitarian and development work in the global south, marking the rise of the so-called humanitarian drones. So following this trend, pilot projects and feasibility studies continue to appear on the world map, as you can see here, including applications such as search and rescue, mapping, and medical cargo delivery, among others. Next, please. Here, if we take a step back, the notion is actually not new. As you may recall, in the last decades also, solar panels were broadly introduced in Africa and Latin America to address the energy access issue. And in the public health domain, we have mobile phones that are rapidly deployed to implement e-health and m-health programs across the developing world. In recent years, biometric information like fingerprints and iris scans started to be collected in refugee camps where food and aid supplies were provided to them. And as the focus of my own research, drones are being increasingly adopted by international organizations with various applications, as we saw in the previous slide. And even in the COVID pandemic, as you probably noticed, drones again made headlines. Next, please. Echoing this emergence of humanitarian technology, humanitarian innovation also became a popular rhetoric. So for example, we had the so-called digital humanitarian movement where every citizen was encouraged to participate in crisis mapping. We have earmarked funds and international conferences dedicated to humanitarian innovation. We also started to see more and more mainstreamed media platforms featuring life-saving drones. Scholars also joined the debate, writing articles and books on the good drones. And grassroots organizations like Away Robotics, who is also here, took the initiative to develop a code of conduct for drone operations in the field. And finally, you have researchers like myself conducting research around this topic. Next, please. At this point, you may have wondered that if drones are used for good purposes, what is the problem? So here is the rationale of my research. First of all, there is a noticeable turn to technology in the humanitarian space in recent years, where this raised questions related to humanitarianism, sovereignty, and equality and access for at-risk populations. Then on the technical level, practical challenges include heightened risks of data privacy, safety, and security, as previous speakers mentioned, and potential misuse or dual use of technology, which is a generic problem for new technologies. And on the societal level, humanitarian innovation may disrupt relations between different stakeholders. It may widen inequality between those with access and those without. And it may bring unintended consequences affecting vulnerable populations that the aid sector is committed to serve in the first place. Next slide, please. So to understand the ethical landscape, we conducted a preliminary research at the onset of our project and mapped out the key areas of concern as shown here on this slide. Overall, the 8th sector serves disaster or disease-affected populations, and the fundamental humanitarian principles are to protect these populations on the basis of humanity. So any proposal for technological innovation in the 8th sector should keep these humanitarian principles as the normative foundation. Next, please. To further zoom in to the ongoing debate and understand what the prevailing perspectives are, we conducted a literature review to map out the knowledge landscape. So as shown here, our review is guided by a defined research question, which involves 3 central notions, namely drones, humanitarian use, and ethical considerations. We then, next please, designed a search strategy to operate the database search. As you can see, our search covered different types of publications, including both gray literature and including both academic literature and gray literature. We then held a multi-stage screening process to select articles from 3 academic databases. Finally, all papers included in the final data set went through a snowballing process where we identified additional papers that were relevant. Next, please. So the entire search, selection, and snowballing were conducted during April and July 2020. And this chart on the screen now provides an overview of the search and selection process, following which the final set of 47 articles were eventually analyzed. As you see, it's actually not a lot compared to other types of, compared to the literature reviews of other topics. So next, please. In the data charting phase, we extracted data around 3 headings, as shown here on this slide. The analysis was organized using a bottom-up approach where inductive categorizations of the issue areas were developed. So we tried to avoid these preconceived conceptions. And to be comprehensive, we took an inclusive approach to define ethical considerations, taking also into consideration the legal and social aspects that are closely linked to ethics, or at least to the respective authors of the selected articles. Next, please. So what did we find? This figure on the screen gives a visualization of the main ethical considerations. Overall, regarding ethical considerations, harm seems most prominent, followed by justice and respect. Regarding harm, discussions focus mainly on ensuring physical safety, in addition to promoting public welfare, as well as individual benefits for the affected populations. With respect to justice, issues related to procedural justice are less often discussed compared to substantive justice, whereby cost effectiveness of drone operations and general responsibility of stakeholders are stressed. Concerning respect, the community aspect is discussed in relation to both acceptance and engagement, while the individual aspect shed light on privacy and information security. About legal considerations, the lack of airspace regulation appears to be a concern alongside ambiguous or inadequate regulatory processes, for example, bureaucracy that hinders drone use, as previous speaker mentioned as well. Finally, with respect to social considerations, public perception seems to be notably represented in the literature, alongside relations between humanitarian organizations and the drone industry, as well as the identity of humanitarian aid providers and aid organizations. In particular, issues related to the effectiveness and accountability of humanitarian aid and reputational risks of the military region of drones appear to be causing the most concern. So next, please. And a more detailed analysis of the ethical considerations reveals the following major trends. Firstly, a key concern for the humanitarian use of drones is the possibility that humanitarian space has become a so-called testing zone to advance the drone technology without necessarily benefiting communities in need. From this perspective, initiatives to test drones in humanitarian operations should assess a wide range of benefits vis-a-vis risks, as well as sustainability of the operations in the long run. Secondly, concerns have been raised that the drone industry may seek legitimacy through the humanitarian space, which may facilitate the expansion into new markets driven by financial rather than humanitarian motives. Also, a focus on drones may deflect the attention of humanitarian organizations away from underlying issues or alternative methods, potentially simpler and more effective ones. Thirdly, there is a fear that the use of drones in humanitarian operations may create distance between humanitarian responders and those in need, which could eventually lead to less empathy for affected populations. These concerns lead to the questions whether humanitarian organizations actually are in the position or have the capacity to manage the development, operation, and procurement of drones, and whether these funds should be spent elsewhere. Finally, these concerns resonate with the general ethical issues related to the civilian use of drones in high-income countries. That is, as humanitarian organizations consider the uptake of drones, they should take stock of their capacities and the sorts of partnerships that will be required to facilitate drone activities, while also be mindful of reputational and relational risks that may arise as a consequence of this type of application. Next slide, please. Finally, I just want to very briefly mention that the review results of this project, of this little literature review, contributed directly to the development of an ethical assessment framework we developed, which aims to provide a practical tool to facilitate field operations in the use of drones in the humanitarian and the development settings. So this framework contains 3 levels of considerations, asking different sets of questions to the potential users. On the overarching level, the ethical values that are most important to stakeholders are outlined to inform the decision making regarding drone use. On the foundational level, resources of ethical support are suggested to facilitate decision-making within a humanitarian organization. And then these 2 sources, they together, they're interconnected, and together they jointly provide a value-based decision chain, as you can see in the middle, regarding whether to embark upon a drone project and how to manage drone operations in a responsible and sustainable manner. Next, please. So with this, I would like to invite you to visit our website for more information. There you have the scientific publications of also 2 field studies I conducted in Nepal and in Malawi in 2019. And then you also have a number of videos and webinars that you can dive into more to the details about this research. And with that, I thank you for your time and attention, and I look forward to a discussion with you all. Thank you.
Thank you very much, Dr. Wang. That was a great presentation, and I believe we are having some questions already coming from the audience. Thank you once again to all the speakers for this high quality presentation. It is now time to move on to the Q&A segment. For this, I would like to pass the floor to Melissa Puerto, who is also an intern at the Resilience to Disasters and Global Conflicts Global Support Branch at UNEP. Over to you, Melissa. Thank you.
Thanks, Aman, and thank you again to all speakers for the insightful presentations. In this Q&A session, we will try to answer as many questions as possible in the next minutes. As a reminder, I would like to kindly ask speakers to turn their cameras on when responding. I am checking all the questions that we have, and I saw some questions already. However, I encourage the audience to address their doubts in the chat box. Starting off, we have a question for Mr. Bartolome. The question is, what advances would you like to see in drone technology? What do you think people should focus on to advance the field? Over to you, Mr. Bartolome.
Yeah, thanks a lot for the question, and really thanks also to all the speakers. It was great. No, I'm not sure I can really answer that question in that way. It would be more around how I would like to see the future of drones. Maybe not only focused on technology, but I think also and to resonate with the last presentation. Maybe I would like to see the future of drones a bit more, I mean, inclusive, ethical, providing really economic opportunities locally as much as possible. Drones should be used in the best possible way to improve citizens' life on a day-to-day daily life. As much as possible using green technology, and that would be great. And locally sourced, locally maintained. I think this is also a lot what I've heard today from the different presentations. The importance of having really this strong local footprint. So this would be, yeah, we have plenty of drone technology experts, much more than I am in this field, to answer maybe more, if you want, on these advances in technology.
Thank you so much for that informative answer. Now we have a question for Dr. Patrick Meyer. The question is, humanitarians can benefit from drones. How can we lessen the apprehension that comes with them? Thank you.
Thanks a lot, Melissa, and thanks also for organizing. I can certainly answer the question, but since Ning has been doing so much more research on this than I think anybody else here, as far as I know, I think she'll come up with far more up-to-date and informed insights on this. But Ning, I don't know. I'm also happy to answer, and if you'd prefer not to. Sorry, I'm putting you on the spot.
No worries. Melissa, could you please quickly repeat the question? I was distracted because someone sent me a message about a question. Sorry. Yeah.
No worries at all. The question is, humanitarians can benefit from drones. How can we lessen the apprehension that comes with them?
Humanitarians what? Sorry, the connection is not good. Sorry.
No worries, no worries. The question that the audience would like to ask is that humanitarians can benefit from drones, but how can we lessen the apprehension that comes with them from a humanitarian perspective?
Oh, okay, well, I don't know if I fully understood the question, but I'll give it a try. So I think the thing is, the humanitarian and development sector, in this sector, we're serving people that, as I said earlier, that are affected by disasters or by diseases. So there is a special duty of care, I think, for the humanitarian organizations and also the humanitarian workers, because these people are already vulnerable in the first place, so they cannot afford to be made vulnerable on top of it, right? So there's a very special duty of care, I think. And it's also important to understand the sustainability of these projects in the field. I mean, it's true that the drones are very powerful tools, and then they also make significant impacts in the field. The question is, for how long do they stay, right? And then, for how long would the community members benefit from such operations? I think this is also something that should be bear in mind by the humanitarian sector. And maybe a third point to add here is that the local capacity building. I think Patrick did a lot of work on this front. And so basically, are we just going to bring this team from the west and the north to the south and then do the operation there and then leave, or are we going to empower the local citizens so that they can take ownership of these new technology and these operations, like our speaker from Malawi, and then they can turn this knowledge and transfer that into capacity. I think this is very important aspect as well. Sorry for the incomplete answer.
Thank you. I think that answers the question very well. Patrick, would you like to add anything else?
No, I think that's spot on. Thank you so much, Ning. Thank you. That's far more informative than I would have been able to do, so I appreciate it. Thank you.
Thank you. It was very interesting indeed. Now we have a question for Professor Escaramuza. The question is, have you encountered any challenges when working with simulations to train the algorithms?
Hi, Melissa, can you hear me?
Yes, we can hear you properly.
So the main challenge is the simulation to reality gap, meaning that it's very difficult to simulate everything that you encounter in realistic environments. That ranges from the dust, fog, snow, rain, lighting conditions. So these are actually the key problems that we actually encounter. We realize that simulation is the only way to test, drones very quickly. Sorry, to fine-tune the algorithms very quickly. And actually, even in automotive, now car manufacturers are actually using simulation more and more to train and test their algorithms. However, we also need a better simulator. So that goes from being able to simulate all the environmental conditions, but also the physics as well, including aerodynamic effects. Thank you.
Thank you so much for your answer. Now we have a question, and I will leave it open to anyone who wants to answer it. This is coming from Josimar Boyce, and the question is, in the previous session, we learned about AI and now drones. Are there any good examples from the presenters of combining AI with drones to address oil spills? I will leave that open to anyone who wants to answer. Or perhaps any other case studies in which we can combine drones and AI to address disasters? This one is open to anyone from the presenters that would like to give some input about how these technologies can be combined.
Well, I think I can add a little bit. So for my case, it's not mainly to do with oil spills, but just using drones and AI in general. So what happens with aerial data imagery, for example, when you collect aerial data using drone cameras, you need to analyze that data. And currently the drones cannot do that on board because they have a smaller computer, so to say, or processor. And then you have to send it to, let's say, online or cloud platforms that have AI functionalities in the background that are able to analyze data for different aspects. So for example, you can be collecting data on a disaster-prone area or an area that has been affected by disaster. And then you can use the AI algorithms on platforms such as Drone Deploy, whereby you can be able to detect that this is a house which is elect, and this is a house which has fallen due to a disaster. So in that way, you're able to feed such platforms with much data, and they're able to learn using machine learning. So I think it's very much possible to detect oil spills by combining drones and AI. And I think it would be of much help if this was happening in real time, whereby the same drone is collecting aerial data, and at the same time, it's able to analyze. But for now, I think they're done separately, whereby you collect data first and then you analyze later.
Thank you so much for that insightful answer. Now we have a question for Mr. Taichi Furuhashi, and the question is, what are the next steps for DroneBird? Do you plan to expand?
Okay, next step. So yeah, our next step is, we are thinking about how to extend our covered area, depend on the agreement. So already I said, so we have only 33 agreement with local government, but there are about 2,000 local government in Japan. So we have to extend to the 2,000. So that is our goal. So next step. Thank you.
Thank you so much. Now I think we have some time for last questions. So we would like to also talk about the ethical use of drones in disaster management. So Dr. Ningwang, it will be an honor if you could give us some input about how the drones for disaster management should be introduced in the context of a vulnerable population and what challenges could arise.
Yeah, thank you for the question, Melissa. I think I have already briefly talked about it in earlier on when Patrick kindly passed me over the question, but maybe just a little bit more to add. So as you know, now we have this informed consent, which is a standard procedure, not only I mean, it's in medical ethics, it's in many areas. We, even for the, when you download an app, you have this informed consent. I do think it's important to bear in mind not to keep this as something procedural or merely procedural, right? So in this process, we should really make an effort to inform or even engaging the community so that we make sure that they actually understand what we're talking about, what the technology is about, and why do we use it, and how are we going to use it, and for how long, and all these questions. So do the informed consent in a more substantial way as opposed to procedural, right? And then another aspect I thought about is this community sensitization. That's also a very standard kind of practice by the humanitarian and development practitioners in the field. And then I think also here, also ensure that it is a two-way communication as opposed to, we're just here to give you a brief information session so that you know it. And then that's not really engaging in my view. Engaging should really include the communities from the start, and along the way, really understand what they need and what is the local need and what is the capacity there, and so that this community engagement or this community sensitization, however you call it, can really make a difference, again, as opposed to just procedurally doing it for the sake of it. I think I'll just stop here for this question. Thank you.
Thank you so much. That is very interesting. We have also a question for Mr. Cameron. Mr. Cameron, I don't know if you can still hear us.
Hi, this is Arian Hopkins. I work with Cam at Dragonfly, and unfortunately, he is having massive bandwidth issues. So I'm going to put his email address in the chat. And if anyone has any additional questions for him, feel free to email him and he will respond ASAP. Again, apologies.
Thank you, no worries. So I think we can have a question for Domi. Domi, the audience is wondering, what are different operations you plan for different drone versions, such as fixed wing and VTOL?
All right, thank you. So we are targeting two operations mainly. So one is delivery in medicine, and then the second is environmental monitoring using the drone cameras. So in the drone delivery, we have one, it's a fixed wing, and the other is it's a vertical takeoff. The fixed wing can carry 0.5 to about 1 kg, while the vertical takeoff can carry about 1 kg of medical payload. The reason why we had to switch from just a fixed wing to a vertical takeoff with 4 rotors, it's because we had challenges on taking off because the takeoff was using bungee launch, so we had to catapult the aircraft. So takeoff and landing was a challenge, but with the VTOL, we're able to solve that. So we are basically focused on those two areas. And also we are much focused on continuous research and development. So the drones that we have now, we're collecting data on their performance. By next year, we'll have done more improvements on them as well.
Thank you so much. That is very interesting to hear. Unfortunately, we are running out of time, so in the interest of time, I will now have to put an end to the Q&A session. Thank you very much, everyone, for taking time to attend this webinar, both speakers and attendees. It was a very productive discussion, and it was nice to hear of so many examples where drones have been used in disaster response and management. A special thanks to our colleagues, Paula, Maxime, Tlamelo, and Thomas, for doing such a great work behind the scenes. Before we close today's session, we would like to remind you all that our next webinar will take place on the 26th of October, and it will focus on the Internet of Things in disaster management. The timing is the same as the one we had today, 3 p.m. Central European Summer Time. See you in 2 weeks and have an amazing day. Thank you.